This is AQA Coordinated Science Chemistry Higher Paper 2 from June 2018, and this is question 6. So we have bleach, a solution of sodium hypochlorite, and chlorine gas is produced when that reacts with hydrochloric acid. And you can see it's a reversible reaction, which will be important for later on. But first, we need to give a test and result for chlorine gas. Now, the first thing to note is that it bleaches litmus paper, but to get to the second mark, you need to recognise that that litmus paper will be made damp. If I move on to 6.2, we've got a sealed flask of sodium hypochlorite and hydrochloric acid, and it's at equilibrium. Why is equilibrium reached in this reaction? In the first instance, we can say it's because the forward and reverse rates are equal. That's what happens when equilibrium is reached. And that's because no reactants or products can escape, and that's because the flask is sealed. We move on to 6.3, and I've brought the equation back here so that we can use it and the diagram. The stopper in figure 8 is removed, HCl is added, we then replace the stopper. What happens to the position of equilibrium? So I've added HCl. Now, Le Chatelier's principle tells us that if we impose a change on a system, the system will act to oppose that change. So the system will try to decrease that HCl. It will do that by moving the equilibrium, and it will shift it to the right-hand side to counteract that increase in HCl. For the third mark, we're then saying that that means we will get more of the products formed. And eventually we get to a new equilibrium. And that's our fourth mark. On to 6.4, chlorine gas is produced when hydrogen chloride decomposes. The forward reaction is endothermic, which is very, very important. Predict the effect of increasing the temperature on the amount of chlorine gas. So if the forward reaction is endothermic, I then need to remember that increasing temperature will favour the endothermic reaction. And that's because the endothermic reaction takes the excess heat energy from the surroundings back in. So the equilibrium will shift to the right, and that will give us more chlorine. And you can see there we get our 2 marks. On to 6.5, what would be the impact of increasing the pressure on this equilibrium? So once again, let's put the equation back up. I've got 2HCl going to H2 plus Cl2. Well, actually, there'll be no change. There won't be an impact. And that's because if you increase pressure, the equilibrium will shift to the side with less moles. But in this case, there are the same number of moles, 2, on each side of the equation.